Hello, Year 8. And in our probability lesson today, probability 4, we're going to be looking at how you can populate a Venn diagram and then calculate probabilities using it. So if you have managed to print out one of these sheets, absolutely great. If not, there's a little bit of writing today. There's a few diagrams to be drawn. Will you make sure you write the title, the date, and the objective in your book, please? Now, what you might not know is a Venn diagram is named after a 19th century English mathematician. The name John Venn, well, John certainly sounds very English, but I hadn't realised that Venn was an English surname, and he was born in Hull in 1834. I'm sure you've all seen a Venn diagram before. It's usually two overlapping circles, sometimes it can be three. Each circle represents specific criteria. And if we have data that satisfies both of those criterias, in other words, if we have a circle that represents one thing and a circle that represents another thing, and it is a piece of data that satisfies both, then it goes in the overlap of those two circles. But the proper technical term for the overlap is actually the intersection. And we'll be talking more about specific parts of a Venn diagram in the following lesson. If a piece of data doesn't satisfy either of the criterias, then it will go outside the circles but within the rectangular shape. So here is an example of a Venn diagram that has already been populated, and what I mean by that is the numbers have been placed into it. We've got a situation where C represents the students that have studied French and D represents the students that have studied art. We have got some students that study French but not art, some students that study both, some students that study art but not French, and then we also have some students that do not study either. So, for example, if we look at this intersection here, these are the students that study both French and art. If we look at the whole circle C, the whole circle C represents all of the students that study French. All of circle D, the 12 and the 24, would be the number of students that study art. And like I say, any number on the outside are students that do neither. So the first question is, how many students were asked? In other words, how many pieces of data does this Venn diagram represent? So all we have to do to answer this question is add all these numbers together. So I can work out how many people were asked by adding those numbers up. So 20, 40, 60, 70, 78. The second question says, what is the probability a student picked at random studies French and art? Well, French and art is the intersection. So that is 12 out of 78. And of course, that fraction cancels to 6 out of 39, which cancels a little bit further to 2/13. What is the probability a student picked at random studies French? Well, C is our circle for students that studied French. So don't immediately go, oh, it's 20, because the whole circle represents the students that study French. So it's actually the 20 and the 12. So it is 32 out of 78. And that again cancels to 16 out of 39. Now, when we have a blank Venn diagram and a couple of sentences describing the Venn diagram, things can be a little bit trickier. can be very easy to put the wrong numbers in the wrong place. And for some of the questions that you'll be doing today, you will need to do this. You will need to take care, read things carefully, and check things carefully. So in this example, it says a class of 32 students comprises of 14 boys and 3 girls that are wearing jumpers. 10 students in total have jumpers. Complete the Venn diagram. So what do we know? Well, it says A, female students, B, students with jumpers. Now, we are told the intersection here. We are told there are 3 girls that are wearing jumpers in this class. So straight away, I can populate the intersection with the number 3. I also know there are 10 students in total who have jumpers. Okay. However, I already have 3 of them here. So I can work out this section by doing 10 take away 3. So this section of my Venn diagram must be 7. Although I haven't been told how many girls are in the class, I can work this out because I know there are 32 students, 14 of which are boys. That must leave 18 girls in total. 3 of the girls are already in my intersection here. So I can work out the rest of the girls by doing 18 take away 3. So this number here must be 15. Altogether, I have now allocated for 25 students. And if there are 32 in the class, the rest must be in this section here. So 32, take away 25, leaves another 7 students there. And these 7 students will be the boys that are not wearing jumpers. Now we've populated our Venn diagram, we can answer some questions. What is the probability I pick a female student wearing a jumper? Well, we know that one. It is the intersection. It is 3 out of 32. What is the probability I pick a student not wearing a jumper? Well, let's be careful here. All of these students, these 10, have jumpers. So the ones not wearing jumpers are these 15 here, the girls that aren't wearing jumpers, and these 7 here. So altogether, there are 22 out of 32 not wearing jumpers, which cancels to 11/16. So today there are some questions for you to try on a question sheet. Once again, they are leveled 1, 2 and 3. There's a little bit more help on level 1, but you are going to have to think carefully. Make sure you get those numbers in your Venn diagram. If you are struggling a little bit with level 1, I suggest you then have a look at my answers to level 1, see if that helps you out a little bit. So remember to check your answers at the end. And as always, if you have any questions, ask in the Ask the Teacher channel.